line test? Yes? So that is a function of x. Now, if we look at the x value of 2 and we ask Gabriella, if we ask Gabriella, wait, didn't I already ask you something? No. Oh, you asked a question. Okay. Then if I ask Gabriella, what is f of 2 now? Do you feel okay with that? By looking at the graph? What do you got? Okay, so where are you getting 4 from? You're going to 2, and you're going up, and you're seeing that, and you're saying 4. 4 and 8. So is that possible? Would it be a function? If you say when you plug in 2, like 2 goes in, it's not possible to have 4 and 8 come out, right? Because then it wouldn't be a function. It's got to be one or the other. So from the picture, can you tell which one it is? Is it 4 or is it 8? And why? 8 because of why? Do you see the difference between these two right here? It may be hard to see for you. Do you see that that one has an open circle? It's an open circle, and see that's a solid dot? The dot implies that it's defined at that point to be this. The open circle means that it actually isn't there. It's empty. So f of 2 here would be 8 still. Okay? Everyone got that? Yes. So f of 2 is 8. So far, if we were in a college algebra class, this function at 2 would be identical to the one above it, wouldn't it? If we just closed off everything and just looked right here, we'd be like, yes, f of 2 is 8. But it's the stuff that's happening on the left and right that's different. So let's take this out. Oh, no, actually, let's ignore what's happening in the middle now and talk about what happens as you come in from the left. So, Arafat? Am I saying that right? Okay. No nickname? Okay, so this is good. Okay. Can you tell me what this function is approaching as I come in from the left-hand side?
So it's from left-hand side to right-hand side, right?
Yeah, moving from left to right towards 2. As we move towards 2, though. So as I come in this way,
It's increasing.
okay, it's increasing to what value is it getting closer and closer to? 8. Does everyone agree?
Yes.
From the left-hand side, as we get closer to 2 from the left, the function's value is approaching 8 still, just like the one before. Brian. It just says Brian. That's it, right? That's you? Okay. So Brian, how about from the right? As you get closer to 2 from the right-hand side, what is the function approaching? 4. 4. So you'll see it goes up and then comes back down, and it starts getting closer and closer to 4. So the idea of the limit is that what we're going to be doing is we're going to be trying to get close to a number without actually ever getting to the number. Because we already know what happens if we get to 2. If we get to 2, it's 8, right? That's what we already know. But the question is what happens as we get closer to 2 from both sides. So from this side, it's approaching 8, but from this side, it's approaching 4. Any questions on that? This is fundamental. You have to see it. It gets hard if we can't visualize this. Yes?
So, like, will a question like that be on the test?
Oh, yes, but it'll be formulated in a different way.
Okay.
Yes. So, no questions on the left and right? Yes?
So, is there any relation between those two? No. Just that they...
No, all we're doing right now is looking at a picture and making sure we understand visually what is happening as we approach a certain value from one side and the other, and how that is different than looking at it at the actual value of 2. Let's do another example.
This only works on functions, right?
As opposed to, yeah, like, doesn't have to be one-to-one. You could do this on a parabola. One-to-one would mean that it doesn't ever Like 1-to-1 would mean it passes the horizontal line test also. It doesn't have to be 1-to-1, but it does have to be a function. Okay, so here's another function. Hope y'all can see that. This is 2, 4, 6, 8, 10. Heidi? Oh, there you go, Heidi. Heidi, what is f of 2? 6. Everyone agree with that? So I just asked Heidi an algebra question, a college algebra question. I asked her to basically ignore everything else and tell me where the dot was at 2. And she said 6, and that is correct. Now, I would like to ask a calculus question, which is to ignore what's happening there and instead look at what happens as we come in from the left. We'll start with the left. And we already met today, so we're not doing that. Emily? Emily, what happens, what is the function's value approaching as I come in from the left-hand side here? 8. Everyone agree?
Yes.
Okay. Now, Alberto?
Yes.
Where, right there? Yeah. What about when we come in from the right?
You can hit 4.
From the right-hand side, we're going to go to 4. Everyone see that? We go up, come back down to 4. So I've shown you now, I think this is our third example. In the first example, I think we should go back and take a look at them real quick. Are there any computer science majors? So all these animations that I'm doing, I wrote in the native language of Mathematica. So this is the code that I wrote to make this little thing happen. Mm-hmm. So if you're interested at all in getting your hands on this code just to mess around with it, it's C+ based. It's not, but it's a lot of built-in functions. So I can provide you this, but you would have to be able to open it in Mathematica. So if you're a CS major and you're interested in this program, I can talk to you more about it because I've got tons of stuff for this. All right, so back to this. All right, get this out of here. Okay, in the first example, let's kind of run through this again. F of 2 was 8. From the left, the function approached 8. From the right, the function approached 8. This was like the holy grail. Everything works beautifully, doesn't it? Everything is just perfect. Everything's basically going to 8. This one, I gave you an example of a function that is still, f of 2 is still 8, but from the left and from the right, it's different, isn't it? It's 8 from the left, 4 from the right. So this is the part that kind of messes things up, right? This f of 2 was 8, left was 8, the right wasn't. This one had more problems, didn't it? From the left, it's 8, from the right, it's 4, but at 2, it's 6. So like nothing matches, right? What about this function at 2? Now you can't see, it's hard to see this, but here's 0. This is 2, and this is 4, all right? Did I not? I can't zoom into this. Sorry. I can't zoom in. I can make it a little bigger. Maybe that helps. Does that help a little bit? So this is 4, and this is 2. And Sophia? Sophia, you get the algebra question. What's f of 2, Sophia? Okay, so good. So you're trying to estimate that this is about negative 0.3. Okay, does it matter at all to you that that's an open circle? That if I tell you that's an open circle there, does that change your answer? What would you then say it is? I gave you kind of a trick question. I'm sorry, but just the way it all worked out. If there's no point there, right, then the function would be, if there's nothing there, then the function would be what at 2? Undefined. Do y'all agree?
Yes.
There's no dot. At 2, there's no dot. So it's an undefined function at 2.
Is that the whole?
It's a hole, exactly. That is a hole in the graph. So now, looking at it from the algebra perspective, closing everything else off, we say, hey, what, sorry, Sophia, right? Okay. Say, Sophia, I'm asking you, like, where's the dot here, right? What's f of 2? Where's the dot? And you're like, there is no dot, right? It's undefined. However, if we switch to our calculus goggles, we do have something happening from the left and from the right, don't we? It is headed somewhere. This is critical right here. This point right here is critical. Our function is undefined at 2. But from the left, is it headed somewhere? Here we come. Here it comes. So let's start marching it in there. You see it? Marching away, marching away, marching away. I'm at 1.9. I'm at 1.99. I'm at 1.999. I can get closer, right? 1.99999. All right, so let's see. From the left, Aaron. Where's Aaron Cagle? Aaron? Aaron Cagle? No? Not here today. That's an easy way to take attendance, huh? All right. Michael Sanchez? Am I approaching something from the left? Does it appear that from the left I am approaching something?
Approaching undefined.
I am approaching undefined, right? I mean, if I get to 2, it's going to be undefined, right? If I get to 2. But see, I'm not getting to 2. I'm at 1.999. And I could go 1.999, 9, and keep adding 9s. Does it appear that the function's y-coordinate is headed somewhere? Does that y-coordinate look like it's trying to get to some place? Look at the y-coordinate here. The y-coordinate is this purple one, right? That's measuring your y-coordinate here. Right now we're down negative 3.8, right? So I'm going to start moving this in again for you. Look at that y-coordinate and tell me where it's headed. I've got to get real close here. See the y-coordinate, negative 0.3? So as I get closer and closer, now I'm at 1.99999. What does it look like I'm headed towards? Negative 0.25, right? Now, it's not negative 0.25 because there is something else out here, but doesn't it look like I'm heading towards that? Does everyone see that? It looks like from the left, I'm headed towards negative 1/4. That is 0.25, right? Now, do I ever get there? It doesn't matter, okay? That's critical. With this idea of coming in from the side, we're not asking, does it get to something? We're saying, is it headed towards something? Yes, it looks like as I come in from the right, it is headed to negative 0.25. The closer I get to 2, the closer that looks like it's getting to negative 0.25. Is this clear with everyone? And Michael, when I get to 2, if I actually got to 2, what would happen? Like if I could step along this thing and somehow just cross over that little horizon onto 2, what would happen? What happens when I get to 2? It's undefined, right? It's undefined. That hole in the graph, everyone, you have to understand that that hole in this graph is infinitesimal. I mean, it's a hole, but can't even measure how wide it is, but there's a hole there. And as long as you're not at 2, this thing is defined. Okay, what about from the right-hand side? Emmanuel? Yes? What about from the right? Do you want me to bring it in for you? Let me hide the middle again. So as I come in from the right, here's the y value. See it?
Yes.
Okay, so what does it look like it's approaching? Negative 0.25. So if I let me pull everything out of here, get all this crap out of here. Okay, we had a hole here in the graph, right? It's like the function was like, I'm fine, I'm fine, I'm fine, I'm fine, I'm fine. And then at 2, it like it doesn't know what to do. And then after 2, it's fine. Well, look at the function. That's a rational function from college algebra, and it has a hole at 0. I mean, sorry, did I just say a hole at 0? I did not mean to say that. Where does it have a hole? Check it out. Go into this function right now and tell me what f of 2 is. Algebraically plug 2 into that. And Marissa, if you plug 2 into this, what do you get on top? What do you get on the bottom? 0, right? And 0 divided by 0 is undefined. And you remember last class I told you the fundamental idea here in calculus was to somehow find a way around this? Somehow to get around this idea of 0 over 0. The way around it is exactly what we just did. We are not going to focus our attention on what's happening at a specific point. Because if we try and go to a specific point, our math is going to fail. Our math will fall apart and we'll have undefined. However, if we get really close to that point from either side, we get answers, negative 0.25, right? And that's what the idea of the limit is. The limit is trying to get close to something without actually ever getting there. Because if we get there, everything falls apart. Okay, now we're going to do more of this. Don't worry. I just wanted you to see 0 over 0 for the first time now. Yes?
And what do those answers produce? Getting closer to the limit, you said that we get answers. What would they produce?
Okay, so remember I was saying, like, can you talk about the speed of something at an instant? And we said that you can't because you get 0 over 0. But see, you can, because what you can do is you can say that from one side it's approaching something and the other side's approaching something. That means at that point, if we could be at that point, it should be what those were headed towards. Okay?
So an approximation?
It's not an approximation because the limit can only go to one place. The limit's headed towards one number and one number only. Maybe I can do it this way. I'm kind of getting a little bit ahead of ourselves, but think about it this way. Let's say that I have a curve again, and let's say I'm trying to find the slope of the line that goes through that point that's tangent to that curve. Does that kind of make sense? The way I could do this is I could pick a second point over here, and I could draw a line through those. Could you find the slope of this line? Like if I gave you those 2 points, could you find them? Find the slope, right? It would be y2 minus y1 over x2 minus x1. It's just your slope formula. All right. The problem with having the slope of this line is that there's a single point. And so the change in y2 minus y1 over x2 minus x1, this would be 0, and that would be 0, right? However, if I imagine taking this point, well, let's take this point and don't move it. Okay, keep that point fixed. And then take that point and start sliding that point towards that point. Look at what happens to the pitch of this line. The pitch of this line would go up first, right? And then what would happen? It would start getting closer and closer to that one, wouldn't it? Now, as long as these 2 points were just barely next to one another, I would have a line. And do you see that slope right here is approaching something? And that's exactly what's going to happen. It's going to be approaching from both sides. We're approaching the same number, even though at that point it makes no sense to talk about slope. That's how we're going to do it. Now, like I said, I'm getting a little ahead of ourselves, but that's where it's going to be used. Okay. Let's see what else we have here. How are we doing on time? 20 minutes? Okay, what about this one? That is I'm interested right now in what's happening at 1. I'm sorry, not at 1, at 0. So here's 1, here's 2, here's negative 1, here's 2, here's 0. So, Juan, what's f of 0 here? So you get the algebra question. Emmanuel, did I call you?
Yes.
1, what's f of 0? It is. Because there's a hole, right? So you have a hole here, and so at 0 it's undefined. So we kind of have the situation we just had a second ago. How about, Frank? How about if we come in from the left? Can you tell where we're headed if we come in from the left? Where? We're headed towards 1. Does everyone see that? If I start walking along this graph and start measuring how high off the ground I am, here's 0.5, here's 1, here's 1.5. So I'm like walking, I'm getting closer and closer to 1 without ever actually getting there. Coming in, approaching. Oh, I have that little, see that little green thing? That's showing my y coordinates. So coming in, getting closer and closer to 1. Ooh, what did it do there? Indeterminate, 0 over 0. Freaks out. Okay, what about from the right-hand side? Edward? Where's Edward? Edward, what's happening as I come in from the right-hand side here? It's also approaching 1. So from the left, we're approaching 1. From the right, we're approaching 1. And at 1, yes, I'm saying that right. As we approach 0 from the left, our y value is approaching 1. As we approach 0 from the right, our y value is approaching 1. At 0, our function is undefined. Yes?
Is there like a certain like name for functions that limits like on both sides are the same?
Yes. Yes, the question is it special when they go to the same place?
Yeah.
Like, do we have a certain like language for it? Yes. It's coming. Okay, this is the graph of sine of 1 over x.
Do they also call that graph the lasso?
You can call it whatever you want. And James, sorry James, you get to tell us what f of 0 is. And I'll give you a hint. I mean, this is 1, -1, 2, -2. So 0's here in the middle. To help you get it, do you have an answer? You think it's 0 because that? Okay, look at the function though. That'll help you. So what happens if I ask you to plug 0 into that function? It's undefined because you'll do 1 over 0 and that's undefined. So does everyone see that this function is undefined at 0? There is a hole here, but my computer is not capable of picking that up, okay? Because there's complete chaos next to it. So this is undefined. I have one more stick there, and you probably know who you are. I'm going to zoom in a little bit so we can see what's happening in there. I'm going to zoom in a little bit more. It's chaotic. It's very crazy stuff happening in there. My computer's having trouble with it because anytime you see jaggedness like this is a sine function. We're supposed to have a smooth curve here. Jaggedness is my computer saying, like, I give up. All right?
So is that a RAM or a graphics card?
It's the program itself. I mean, it can only plot a finite number of points. Right? I mean, the machine has to just make a curve. It basically plots points and connects them. But when it has too many points that start becoming all over the place, it starts connecting them and it looks jagged. You could ask the computer to do a better picture and it would just take more processing time. But it doesn't matter because this function becomes infinite. Like what you're basically doing with this function is you're trying to cram, it's like taking the entire sine function and trying to cram it into a smaller and smaller space. And you start to get this craziness. Uh-oh. Rasul? How do I say that? I'm perfect. Rasul? Rasul? You got picked. From the left-hand side, any ideas of what this thing is approaching?
Left-hand side,
You start coming in the left-hand side towards 0. Do you have any idea what that thing's headed towards?
Like the up, like increasing.
Is there a y value that it's headed towards? Like on this right here, as we came into 0 from the left, it was approaching 1, right? But can you say anything about what this one would be approaching as you come in from the left? So let me help you. So I've erased that. Okay, does that look like that's approaching anything?
Yeah.
What?
Yeah, it's approaching to, I think, the one.
We're talking about the y value, the up and down. If I start moving along this curve, is my finger starting to head towards one number only? It keeps oscillating, doesn't it? I mean, like, I'm not headed anywhere. I just keep going like this. And I keep doing this faster and faster and faster. I can actually have the computer do it, but the computer starts to freak out. So here it comes. Where is it? There it is. So here I'm going to start bringing this in. Watch that point. It's just going to start bouncing around everywhere. Up, it freaked out. So here it goes. See it? It's freaking out. See, it's not leveling off to anything. Therefore, from the left-hand side, it is not headed towards a specific number, and therefore, we will say later, I'll have the definitions up here, we will say that this limit does not exist. So you got kind of a trick question there. So I think you've paid your debts to the karma gods now. Yes?
Unless between like -1 and 1, you just say like it doesn't exist.
Well, it's because of the oscillation. That's what's making this thing not be like all the others. All the others were nice curves, weren't they? And then they eventually went somewhere. You can have functions that start to behave very strangely. Okay? So we have a function that's not defined at 0, and as you approach from both sides, you start to get this oscillation, so you can't say it's headed towards anything in particular. This is just to show you that there's a large variety of things that could happen here. All right, how about this one? We're back at the beginning of the stick, so we'll just take volunteers at this point. I'm interested in what's happening at 0. So who wants the algebra question? What's f of 0? Undefined, right? Undefined. F of 0 is undefined. What happens as we approach the function, approach 0 from the left-hand side? Tell me what my y coordinate is doing. Where is it going? Where's that? Which one? Negative infinity. So from the left-hand side, this function is diving down to negative infinity. What about, did I say right-hand side? From the left-hand side, it's diving to negative infinity. From the right-hand side, it's going up to positive infinity. So here, f of 0 is undefined. The limit as we come in from the left is headed to negative infinity. The limit as we come in from the right is headed to positive infinity. What's f of 0? What's that? Undefined. Because we get division by 0. Okay, what's the limit as we come in from the left side? It's headed towards positive infinity. From the right-hand side, positive infinity.
Is this that one you're talking about where that special term, they reach the same result?
Yes, that would be a case where they're both sides are going the same place.
So what would that be called?
We would just say that the limit exists.
The limit exists?
The limit exists. But it's coming. I'm about to give you the general definition. Yes?
So these have no holes or nothing defined, right? These that you showed, or this one.
If you have no what?
It doesn't have to have a hole in it or a defined one. Or was that just something you were showing us?
From earlier?
The first one,
Mhm.
all the ones you showed us. at first had like either a defined point or
Mhm.
a hole in them.
Yes.
So these don't have.
These don't, yeah. So they don't have to, you don't have to have holes. And we have a whole variety of types of functions out there. Piecewise, this is a negative power function. When you start looking at all the different functions we have out there, we can have all these different scenarios happen where we have things going, maybe there's a hole, maybe there's solid dot, maybe there's an asymptote. For us, what we're trying to put together right now is the main difference between asking what's happening at a point versus what's happening as we approach the point from two sides. So this is the kind of general idea behind everything. And I know you can read, but I will just kind of go through this. It says basically, when we find the limit of a function at a point x equals a, so I've been saying like what's 0, right? What's happening is 0, that's a. So when we're asking, when we're talking about the limit of a function near a point a, we are inspecting the behavior of the function near a. Limit corresponds to being near a, not at a. We do not care about the actual value of the function at a. When we inspect the behavior of the function, we can approach a from the left or the right side. When we approach from one side, one of the sides, one of the following can occur. These are the only possibilities of what can happen as we're approaching from a side. Either the function approaches a single value, like it goes and it's headed towards 8, right? Or it goes and it's headed towards 1. That's one thing that could happen. It can also oscillate infinitely many times, like we just saw a second ago, right? Or the function approaches either positive or negative infinity. Those are the only three things that can happen as we're coming in from the sides. It's either going to go somewhere, oscillate, or jump, or like go up forever or down forever. Remember, we do not care what's happening at the point. This is what makes this a calculus topic. We don't care what's happening at the point. Okay, so now we talk about what are called left-hand and right-hand limits, which we've already been doing, but now we're starting to put some technical terms to them. As we discussed above, the limit involves inspecting the function as we approach x equals a. We approach from the left or the right. When we approach from the left, it's called the left-hand limit. And when we approach from the right, it's called the right-hand limit. Now notation. So if I want to ask you a question, like, hey, look at this function and approach 0 from the left, how do I tell you that? I could write it all out, right? I could just write it in words. But this is the actual notation that we use right here. That right there. I'm going to write a little bigger. Lim x arrow to a, negative arrow on top, f of x, right there. That notation right there means, here's what that means. It means, hey everybody, take a look at this function, okay? Here it is, f of x. What I'd like for you to do is I'd like for you to let x approach some number a. We were approaching 2 or we were approaching 0. And then this little symbol right here tells you whether or not I want you to come in from the left or from the right. Notice that this negative is like superscripted. It's up and to the right. It's not in front of the a. It's up here. That means come in from the left. Left. Think of the number line. Negative numbers are over here, so you can come in from this side.
Yes.
Sure? Okay. So this is what we call a left-hand limit. Now, if our function actually goes to a number, if it goes to something, then we will call that answer L. And that would be the limit of the function. It would be, in this case, you know, whatever that number is, like 8 from earlier. Now, if I want you to do a right-hand limit, the only thing that changes in the notation is that I put a little plus here. And that means you're going to come in this way. Now, what if I want you to look at both sides? What if I want you to actually do both of them and see what happens? Then the notation for that is that I will not put a plus or a minus. So if there's a plus, you come in from the right. If there's a minus, you come in from the left. And if there's not a plus or a minus, you have to look at both. I know that's a little confusing, but I don't make this up, okay? This isn't my idea. So there's no sign there. Okay, blah, blah, blah. I can let you read this. Okay, so let's look at this. See if we can wrap our heads around this notation now. This is telling us to look at this function right here. And it wants us to approach 2 from which side? The left side. And do we all agree that the answer is 8? Because when we come in from the left, here's 2. If we come in, the function's value is approaching 8. Here, we're looking at this function. We're approaching 2, but this time we're approaching 2 from the right side. And do we all agree the answer would be 4? Is it 4?
No.
Why not? Because what? Let's take a revote. Let's take a revote. Is this correct? Is the limit as we approach 2 from the right equal to 4? Vote. Yes? In favor? Changed your mind? Do we care about what's happening at 2? No, we do not care what's happening at 2 because we're looking at a limit. In a limit, we ignore this completely and we just ask ourselves, what are we approaching as we come in from the side? Okay? So this is correct. The limit of this from the left is 8, from the right is 4, and what's happening at 2? What's f of 2? 8. Look at this one. Limit as x approaches 2. Do you see a plus or minus there? Which means you have to check both sides. And from the left-hand side, as I approach 2, from the left-hand side, where am I headed? 8. And from the right-hand side, where am I headed? 8. They're both headed to the same place. And that means I can write that this is 8. Because both sides go to the same place. What if they didn't? Look at this one right here. Okay? I want to look at this function and approach 2 from both sides. Because there's no plus or minus, right? So here it is. Approach 2 from the left, what are you going to? From the right, what are you going to? 4. Those aren't the same answers. And when that happens, we will say DNE. Does not exist. Does not exist. DNE. When the limit from the left is not equal to the limit from the right, then the limit does not exist. When they are equal, then the limit does exist, and your answer is just whatever number they're going to. Like in the previous problem, they were going to the same place, right? So the answer was 8. But if they don't go to the same place, then the limit doesn't exist. What's the left-hand limit here? At approaching 2, what's the left-hand limit? What's the right-hand limit? 4. So left-hand limit's 8, right-hand limit's 4. They're not the same, therefore the limit doesn't exist. Does the left-hand limit exist? Yes. Does the right-hand limit exist? Yes. But the limit as you approach 2 does not exist. That's weird, right? The left-hand limit exists, the right-hand limit exists, but the limit doesn't exist because the limit implies that both of those go to the same place. It's weird, but that's, the way it is. Remember this one? Remember this one right here? If I ask you, what is the limit as x approaches 2 of this function? Would it exist or not? It would. I kind of already gave it away up there, but do you see why it would exist? From the left, it's approaching something. From the right, it's approaching something, right? Do we care that it's a hole in the middle? We do not.
But on a function like this, how do you know which one to start with? Because if you started on the up half before the pass until it would go to infinity?
Because I'm asking what's the limit as x approaches 2? And 2 is right here. That's a great question because we kind of lose sight of that a little bit sometimes. Like, you know, are we over here? No, because we're approaching 2 from the left and from the right. Yes. Yes. I'm out of time.
Other one on top. So what was the difference again? If it's defined or not? If it has a hole?
This has nothing to do with the limit at all.
What does that have to do with that?
What this has to do with is if someone asked us what's f of 2.
Oh, okay.
Right? Like if we want to know the value of the function at 2, we could tell them 8. But that has nothing to do with the limit. I really think that you need to try and take away from this picture right here when you're thinking about limits. This whole idea of ignoring what's happening here and just be thinking about what's happening from the sides. So do your homework for 1.2 and start your homework for 1.3. I'm not done with 1.3, but I will take attendance today off of the sticks. So I think there was only one person who wasn't here. Y'all have a great weekend. I will see you. Where's that sign-in sheet for the bonus thing? Anyone want this?